Okay. Good morning. So, any doubts in yesterday's class? Yesterday, whatever we studied, do you guys have any doubt in that? Yesterday, who all saw the machines? Who all saw the machine doubt? Any doubt in that? In that machine, how the machine is? Now we will slowly we'll start the machine. I'll show you how do we move the axis and everything. First, we will have a theory session here. Maybe this 2-hour class now. I will divide it such that 1 hour will be the session here, and 1 hour we will see the same thing down practical. Let me see the availability of machine and everything. I'll plan it like that. How the axis moves, all those things you will be studying down itself. Okay. So now we are going to safety and measuring tools. Safety and measuring tools. So safety, what is meant by safety? What is meant by safety? Safety of the operator. Only operator? Machine, safe, operator, everything, right? Why we need safety? Why we need safety? To avoid accidents. To be basically to be safe, right? To be safe, so that there is no injury. Because once there is an injury, what will happen? At the end of the day, why is a company working? Obviously to get money and profit, right? Once a person gets injured, the operator gets injured, or the machine gets damaged, what is going to happen? The work is going to stop. And each minute a machine stops is going to cost money. You are going to get loss. So basically for the and obviously once we are injured, humans are injured, who is going to suffer more than us? We are getting injured, but who is going to suffer more than us? It's who's there in our home, right? Be it our parents or our relatives, close ones, they are going to suffer more. We can just, once we got injured, we'll be just suffering the pain, but they will be suffering more. They will be suffering the mental pain. We are just having the physical. So always it is that we should be safe. Now, so I told you safety. Why? Because safety protects you and your teammates. Then avoids injury and machine damage. So your part should be basically your safety. Because the company part will be basically the machine safety. For company, they will see only the machine. Okay, they will see the people, but more important for them will be the machine. So when we care for ourselves, the machine will be okay. But always the safety action, how it will happen? Because of our mistake only. Almost 90% of the time, it will be our mistake. By mistake, we will do something, and that will be affected in the another way. So, and it will, once the safety is followed, it will keep the production super smooth. There will be no problems in that. So, what are the basic workshop safety rules? Basic workshop safety rules. What are those? First thing, wear proper dress. Proper dress, or what we say that? PPE. PPE. It is personal protective equipments. That's a full form of PPE. That's the most important thing in any workshops. You have to always wear proper PPEs. And then, no loose clothes. No loose clothes, no jewelry, no long hair. These are all basic rules. When I think now which is that 94 I don't know. Earlier, when there was the student was getting into a college called NTDF, where I and all studied, they used to do. First, they will put our hand like this and make sure the hair is not coming on above the head. If it is coming, we are not allowed to enter the college. That was the rule in the college earlier. In most of the companies, some companies also followed that because there are chances that it gets stuck. Understood? So, what are the main PPEs? What are the main PPEs? So, why PPE? For that, why PPE? Because in the company, we are wearing this and going for impressing others. We don't want to impress others, right? What we have to do? We have to protect ourselves. Then, the main thing, safety shoes, aprons and gloves. Why? Safety shoe. Because in a company, in a tool room or in a machine shop, you are going to handle heavy things. There are chances that it gets slipped or fall on your legs. So at that time, what is a safety shoe? A safety shoe is a shoe where in the front part of the shoe there will be a metal covering. There will be a metal covering. It's a heavy shoe, but there will be a metal covering. What will happen? When something falls, it will save your leg. Instead of just cutting off your leg, it will save your leg. Then goggles. Because yesterday you saw when the CNC machine I showed, there are chips. Chips in the sense the dust which comes. So when a spindle rotates in full speed, these chips are likely to fly. And there are chances that it will go directly into your eyes. And our eyes are so sensible, it will get damaged very easily. So, always when near the machine, wear the proper goggles, not just a glass. It should be there with glass with side covering and everything. That has to be. Now, here you can see on the head we have hard hat, not cap. It should be a hard hat or a proper safety helmet. Then we have the safety goggles. Here you can see the basic safety items required in a workshop. These are the goggles. We have the gloves. Why gloves? Because after machining, the items may be hot. There are chances of burn injuries. Okay. Second thing, there are chances that after the machining, there will be something called burrs. Burrs is nothing but when you machine a material, in the corner there will be a small sharp residue. A sharp thing will be there in the corner, which may not be clearly seen. It will be there. If you look carefully, you will see. But at that time, when you touch it, there are chances that we get injured. So that's why we have to wear gloves. Then earplugs, not earpods, earplugs. Earplugs, why we have to use? Because some CNC machines, see, our ear has a limit. To hear the volume. Continuous exposure to long noise will be dangerous. Even when you are using the mobile phone and you are hearing songs in the earpods, even your phone will warn. Continuous usage of earphones will damage your ears. Right? So the volume is getting automatically reduced. After hearing for some time in full volume, the volume will automatically get reduced. Right? So what's happening in the CNC machine? The sound. What is the measurement unit of sound? Decibels. Right? In the CNC, the sound can go above 90 decibels. It can go above 90 decibels. And if it is some special material, the sound will go too much high. So in such cases, you should always protect your ears. So that sound does not affect your ear much. That doesn't mean that tomorrow go to company, sir, I don't have earplugs, so I'm going to put in the earbuds. That is not good. The earbuds is not good. Earplugs, proper earplugs. Then we have the hard hat. Why is the hard hat? Sometimes something may fall on your head. Cannot tell anything. Or you slip. CNC some coolant fell down. By mistake you slip. You fell. In order to save from hitting somewhere. So it will hit also, the impact will be taken by the helmet, not by the head directly. That's why we have to use the hard helmet. Then I told you about the safety shoe. Safety shoe, I think he has a safety shoe. He has worn a safety shoe. That is a safety shoe. Aniket. Which will be heavy. It will be little heavy. But the front part will always save us. All the companies, now almost many companies, they have made mandatory. The company itself are providing safety shoes to their employees. Because there are injuries happening. The company is getting losses. They have to take him to the hospital. They have to pay for that. So that will be some costly. That costs more. A safety shoe will cost around 750, 850 or something like that. So that is better, na? Then we need the apron. Apron is there. Apron is basically for protecting our dress and also ourselves. We can sometimes these tips may come into our body. To protect that, we will be wearing the apron. Gloves. Now, what should we do before starting the machine? Before we start any machine, the basic things we have to do are, first you have to check the surroundings. Check the surroundings. Why you have to check the surroundings? What is the purpose of checking the surroundings? First thing, to see if there is any oil leaks. If there are any oil leaks. If there are any other issues. All these things has to be checked properly. Then, second thing, the machine is clean. The machine is clean. And what happens? You might have seen the X and Y axis yesterday in the machine. Those who have seen the machine, they might have seen the X axis, Y axis, the movement. So, if in that movement, somewhere, some chip or anything is stuck, this movement will be affected. Because you know, our machine has a very fine accuracy. The movement. So, our machines normally have 5 micron accuracy. So, that accuracy will be affected if there are some obstacles. Then, the tool which we load should be properly fixed. It should be properly fixed. If it is not properly fixed, there are chances that it may fall down, the tool may break, and the machine also may get damaged. Then we have to see that the workpieces are clamped tightly, properly. The workpiece should be clamped properly. Because otherwise what will happen? The cutter will come. It will start making the cut. The workpiece will go its own way. The cutter may break or the dimension will completely get changed. Our design will completely get changed. So always you have to make sure the workpiece is clamped tightly and properly. Sometimes what happens? We will clamp the workpiece using clamps. We will clamp it. Okay, we clamp. But what will be the mistake sometimes? In our clamping area, the tool will go. Tool will have to go in that area. Whether the tool knows there is a clamp there, tool doesn't have any sensor. We are giving the instruction, go here, go there, go there. Tool is following that way. When there is a clamp there, it will automatically go and hit it and the tool gets damaged. Sometimes what happens? After the work, we will always lift the Z axis. So that should be lifted so that it moves properly. There also, what will happen if you don't move sufficiently? If you don't move sufficiently, there are chances that the cutter may again break. I'll show you some videos of such errors. I'll show you some videos. So these four things has to be taken care importantly. And what should you do during machine operations? During machine operation, when the machine is running, you have to always keep a good distance. Keep a good distance. See, how much ever we clamp, we cannot be sure. Sometimes the piece may fly. The job may fly and come to us. Or even the cutter may break and come to us. So what we will do? If this is the machine door, never stand straight in front of that. Even if the door is closed, stand in a side. Stand in a side with always your one hand should be near emergency stop. Near them. Why? If you feel you have to be very careful about all the things. Any sound difference you feel, any sound difference, any vibration, anything you feel extra, not like normal. If you feel it is not right, press the emergency. Press the emergency then and there. Then check and then continue. Check and then continue. Otherwise, if you have a doubt, don't do. Any doubt, stop the work. Okay, maybe your doubt may be genuine or it may be a false alarm. But sometimes that doubt will save the machine and the work. So keep safe distance. Never touch moving parts like the cutters or anything. If it is moving, never touch them. Then, operation I told you, you should be very careful about what is happening there. From the distance, check that. And then be ready to press the emergency stop. Always. Then after the operation, once the work is complete, what you should do? You have to turn off the machine properly. And turning off means once the machine is you are not running, always keep the emergency stop on. Emergency should be on when the machine is not running. Emergency should be pressed. Because sometimes for cleaning and all, you will sometimes enter the machine. Or you put the hand inside. By mistake, someone else comes and presses something, it will turn and you will get injured. So always, when you are working, after the working, press the emergency button on. Some people will not do because they will say, oh, this alarm is sounding. When emergency button is pressed, the alarm comes continuously. So, but some people will say, the sound I don't like, so I am not pressing. No, you have to keep the emergency alarm pressed. Emergency stop pressed. Then, always the chips should be cleaned. Once all the work is over, the chips has to be cleaned regularly. Then the area should be kept clean, and we use the pneumatic air. Whenever we use air, don't use it directly. Don't use it directly on the thing, slightly on the angle or something you can do because there are chances that it may come to our face directly. Then as I told, emergency stop. Yesterday I showed you the emergency stop button in the machine. It will be a red big button which stop all the motions. It will stop all the motions immediately. Now next thing, fire safety. Once you go to a workshop, you have to always know. You have to always have it in the mind. Where are the fire extinguishers kept? Where are the fire extinguishers kept? Never think that, okay, I am not going to use it. I don't want to know. Because maybe at the time of a fire, you may be the person near to the fire extinguisher. We cannot predict anything. So always you have to know where fire extinguishers are kept. Along with, we should also know what type of fire it is. The fires are of different type. What are different types? We have electric fire. We have electric type of fire. We have oil fire. All those. Each fire has to be dealt in a different ways. If you see a fire extinguisher, you will see that it will be marked as A, B, C, K. All those things will be marked because each fire extinguisher has separate purpose. Sometimes it will be written C, D, E, something like that. So each, that I will explain later what are the fire types. That is not important here now. But that is, you have to know where it is kept, where the fire extinguisher is kept. Then, if it is an electric fire, what is an electric fire? Short circuit, with a fire which happens due to short circuit. If it is an electrical fire, you should never use water. What will happen? Water. We will get shock in reverse. Right? Then, if you see a fire, inform your seniors immediately. Main thing, any fire happens, don't panic. Do not panic. Be yourself and do what you can. Getting panicked is not a solution. What are the common safety mistakes? Common safety mistakes. First thing, rushing the job. Rushing the job. What do you mean by rushing the job? Rushing the job means the work is urgent. Someone will tell you that work is urgent. So what you will do? You will think, okay, we don't want to check any other things. We'll do it fast, do it fast, do it. So what will happen? We will not. Sometimes the tightening will not be proper. The proper centering will not be proper. All those things will happen, and that will be a reason of injury later. Then, not wearing the PP. So I don't know PP. Why? All those thoughts. No. Then loose tools. Sometimes the tool may be loose. That we will ignore. Little looser, it will be tight. That things. Then overconfidence. Overconfidence. Always remember, we are not 100%. Every day we are learning new things. Every day there may be some people in our juniors who knows more than us. Our confidence will kill us itself. So never be overconfident. Okay, so major safety rules on the shop floor. What are the major safety rules on the shop floor? First thing is, most of the shop floors, MNCs and everything, they will have a line marking system. A line will be marked. You can see in this image, the yellow color lines or the yellow color, green color lines will be there. There will be a special way where you have to walk. Sometimes your work position will be here. In a factory, your work position will be here. You have to go here for the stores or something. There will be dedicated walkways which you have to follow. But you should not think, okay, we'll go fast and come. The work is urgent. You should not go directly like this. You have to follow the proper walkways, dedicated walkways. Then, never, whatever situation it is, never run. Never run in the workshop or a tool room or a CNC shop. Why? There will be a tripping hazard. What is tripping hazard? Something is on the way. Your leg got cut and you will fall. Whatever it is, be careful about your surroundings and walk calmly. What? Never run. Then, heavy objects, when you lift heavy objects, always do it with a crane or ask someone's help. Or when you are taking an item from the bottom, there are proper bending procedures. follow the bending procedures. Why? Because that will save your back. Then handle tools and measuring instruments very carefully. The tool should not be handled just like what to say, or throwing it away or holding everything together. Because this will, in a measuring tool, it will affect the accuracy. Then do not touch any machine parts or do not touch anywhere without proper training or instructions. Any accidents or damage or anything, report it immediately. You have to report it immediately to your seniors. Then, or the floor area, make sure that, especially near the CNC, because there are always chances that the coolant may come out. Coolant may come out. So always make sure the floor area is clean. Floor area is clean. And before starting any CNC machine, always check that the air pressure is normal. The air pressure will come from the compressor. So this compressor air pressure will be minimum. We need minimum, for example, 4.5 bar pressure. We have to check that the air pressure is normal. We have to check that all the hydraulic oil, lubrication oil, spindle oil, all these are in correct level. We should never ignore all these things. Always check the levels. Because sometimes some machines, okay, nowadays most of the machines, once the work is stopped, we can start from there itself. But some machines which we use won't have that function. Once the work is done, once the work is stopped, we have to start from the first. Start from the first. So before starting, if you don't check this, what will happen? Because of this oil issue, the work will stop midway. And then you have to restart from the first. Imagine you are running a 14-hour program. Already 13 hours is complete. Oil got empty, the machine got stopped. Imagine restarting the 14-hour program from the first. Is it practical? Is that 14 hours better or just checking the oil level for 2 minutes better? Oil and everything for 2 minutes is better. Then check coolant level. Coolant level, is it... see, I told you, the coolant level from the bottom, from the motor, it will go up, it will come to the tool, it will flush out all the chips, it will come back. But, so it is the same coolant level being used, but there are chances that the coolant level will get down because there are chances of evaporation, there are chances of leakages, there are chances that someone opened the door and the coolant went outside completely. So this is always weekly once we have to check the coolant level. And along with that, we also have to check the coolant percentage. See, how is this coolant made? The coolant will be white in color, you might have seen that. So what we will do is, normally we will use 5% coolant. 5%, 6%, 10% coolant also people use, depending on the metal being cut. So what we will do, we will take DM water. What is DM water? Demineralized water. Not distilled water, demineralized water. So what we will do, we will use 5% oil. 5% oil means we get the coolant oil. So if you are using 100 liters of DM water, we will use 5% of oil in this. Means from the coolant oil, we are using 100 liters. What is 5% of 100 liter? 5 liters. So we will use 400 liters, we will put 5 liters of oil in it. 5 liters of oil. So our percentage will be 5%. So some material, some coolant companies, they tell this much of percentage of oil has to be put in the liquid. So we have to continuously check, at least weekly once. One is the level and one is the percentage content. Sometimes what we will do, we will not mix the oil, we will just add water. When the coolant is low, we'll be adding just water. So one time, two time we add, it's okay. But when we add more, this percentage will come down. That's why we have to check that percentage continuously. Then we are going for the measuring tools. What are measuring tools? What are measuring tools? Huh? Something that is used to check the dimensions or the sizes. Huh? Okay. Why we have to check it? Because we need to know what size we are dealing with, what is the size we will get finally, all those things. Correct? We need it right. Now, what is the most common measuring tool we have used? Vernier caliper. I am just asking the common thing. Forget about the vernier caliper and all. Measurement tape, scale, normal scale we use. In the machine shop we go, we won't use normal scale, we will be using the steel ruler, steel scale. We will be using only the steel scale. The plastic scales will not be used. We will be using the steel scales. So, when you have a measuring tool, what we will do? How we will select a measuring tool? I want to measure something. How we are going to select the measuring tool? Say size of the work, one thing. Yeah. Based on size, we will check. Then we are measuring the final product. If you are measuring the final product, finished workpiece, we will be using more accurate ones. We will be using more accurate ones like the vernier caliper or micrometer or anything. But we are just measuring the raw material. What is the raw material? Raw material. The workpiece before the operation. Before we start the operation. So, should the raw material be accurate? Raw material accurate beda. How size undo? For example, our piece is 50 into 40 mm. Namage raw material ಸ್ವಲ್ಪ 10 ಜಾಸ್ತಿ ಇಂದ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ 10 20 because for the clamping and everything. So for those things we don't need vernier caliper or anything. And we will be using the steel rule. Scale saku. Scale alli minimum ಎಷ್ಟು ಇದಾಗುತ್ತೆ. The measurement we can take in a scale. Minimum, not maximum. 1 mm. Hello? 1 mm we can take. But in the vernier and all, the minimum we can take is 0.02. 0.02. Now, yesterday I told you one thing. Once more I am asking. 1 mm. How much microns? What is a micron? I told you yesterday about micron. Remember? 1000 microns. 1000 microns. Right? 1 mm is equal to 1000 microns. Why this word is important? Why is micron important? Because when you go into the factory, when we work on the CNC, all those things we will be dealing only with, they will tell the customer, we are doing work for the customer, right? They will tell, they won't tell we want 1 mm, 2 mm or 0.5 point. They will tell us we need 5 micron accuracy. We need 10 micron accuracy. We need 1 micron accuracy. When they tell this 1 micron or 10 micron or 20 micron, we should not get confused. We should not get confused. We should be knowing. So always keep in mind. So 1 mm will be so 1 micron equal to how much mm? What will be 1 micron? 0.0001 mm. Okay. So always remember 0.001 is 1 micron. 1 mm. 001 mm is 1 micron. 0.005 mm is 5 micron. 0.01 mm is 10 micron. 0.05 is 50 micron. Always remember this in your mind. Because they will tell us, the customer will tell us, we need 10 micron accuracy. We need 5 micron accuracy. Or the tolerance. There is something called tolerance. What is tolerance? Tolerance. See, when we, for example, we are going to buy a cloth. We need 1 meter cloth. Will he be giving exactly 1 meter? There will be some 10 centimeters or 1 centimeter. 1 centimeter will be up or down. Right? Up or down. Will we accept it? Just 1 centimeter. In the case of cloth, not on the machine I am telling. In case of cloth, we will accept it. Hardly it is 1 centimeter. It's okay. So this 1 meter. So we will be getting plus or minus 1 centimeter. Right? This is acceptable. This plus or minus 1, whatever value is there, that is the tolerance we tell. But when we come to the machine or the CNC operation, this 1 centimeter will change. For example, what will be our dimension? What will be our tolerance? It will be like, for example, I'll give you an example. We had a work. My earlier company had a work. So the workpiece, the job, the dia of that was to be maintained 1.53 mm. Dia 1.53 mm ka pin. Imagine the size. Dia 1 mm. The diameter is 1 mm. And we had a tolerance of plus or minus 0.15. Dia 1.53. Okay, make it 1.50 for example. It was 1.53 in the expert. 1.50 plus or minus 0.15. If the line is told like this, what will happen is 1.500 is the size. 1.5 mm. Right? They are telling it can be between plus or minus 0.15. So, plus 0.15. How much it will be? 1.650. Right? Minus 0.15. How much it is? 1.35. So that means they will accept the work. When we check the dia, for example, this dia is 8 mm or 12 mm. So like that it is 1.35. They will accept the work if when they measure, the measurement is between 1.35 and 1.65. This is known as tolerance. This is the basic thing. We have too much tolerance, bigger tolerances. This is just for your understanding I told. Sometimes the work will have the tolerance of plus or minus 1 mm. Easy for us. No need of any, CNC or the manual machine also we can do. Sometimes we will have 0.5. Sometimes we will have 0.15. Sometimes there are chances that we also have plus or minus 0.05. 0.05. And sometimes this tolerance need not be plus or minus itself. Now I written plus or minus. Sometimes the tolerance mentioned will be 15.32 for example plus 0.15 minus 0.00. Like this also we will write. If it is like this, what will happen? The accepted values will be, the minimum accepted value will be 15.32 itself because minus 0.00. Then maximum will be 15.47. The work should be between these two things. So every time we have to check, right, each pieces. Without checking, can we give the customer? So for these calculations, we need the measuring instrument. So what are the common measuring instruments? Before the how are the measuring instruments has some classifications. We classify it into few steps. What are this one? It is classified into precision instruments. We have non-precision instruments. We have line precision instruments. We have end-to-end measuring instruments. We have direct measuring instruments and indirect measuring instruments. So precision, ashtu precise irbeku. What do you mean by precision? Precision andre exact. Exact. For example, 15.32. We need 15.32 itself. Athra use ಮಾಡೋದು precision instruments. Non-precision is scale alone. In scale, can we get 15.32? 15 we will get. Or at least somehow we can say this 15.5. 15 to 16 we will say 15.5. But we won't get. So that is a non-precision instrument. What is direct and indirect? In the school geometry box, there is one thing we used to just make pain for others. Won't use in the college. Something like this. Remember? Divider. What does a divider do? That is compass. That is compass. Divider, we just use mainly to divide it. But what we'll do? We will take the divider. If there is a line, we'll keep the divider here. Then take it to the scale and check the size. Correct? Is that direct? No. We are taking the measurement, then taking the depth. That is the indirect. That is the indirect. Direct will be which we take the measurement directly. So we'll go for types of some of the examples. Steel ruler. Steel ruler. What is a steel ruler? Which we most commonly use. So most commonly used thing, it will be it's a non-precision linear measuring instrument. It's a non-precision. It's not precision, it is not, because we cannot get the exact value. It will be made of steel and graduations. What are graduations? The lines, the markings will be marked in both inches and centimeters, which we have to convert to mm. Normally this inches value we won't use. We will use the mm only. And then behind that, white tool room, everywhere you can see the tool, this one. We have something called tapping and everything. We are making the threads. So behind the steel roll, there will be all the data which you can use for copying in the exam. Yeah? And finding the values in the tool room. That is steel roll. Then next is the calipers. What is a caliper? As I told, it is a transfer. I told you the divider. Calipers are different types. We have internal, external, all those things. Because see, Imagine we have a piece. We have a piece like this. We need to measure the internal size from here to here. Can we take it directly? No. What we will do? Itra transform the calipers tekondu. We will put it inside, take it out and check the dimension. Okay, main aagi we use the calipers. It's type outside caliper. The inside they are like extra. So when you use it, you will get to know. Then next is the most important thing. Vernier caliper. How many of you have seen a vernier caliper? 1, 2, 3, 4. Okay. So a vernier caliper is something like this. Something like this. This is made of plastic, but vernier caliper will be of steel. Okay. Now, vernier caliper, you can see we have many parts for this. We have the main slide, vernier slide, everything. We can use it for here. This part we will use for the outside diameter. This we will be using for the internal diameter, inside diameter, and this will be using for the depth. Understood? It's just we have a detailed class on vernier caliper. Don't worry. Since we are taking out measuring tools in common, I am telling it fast. So vernier caliper, see, this is the we are checking the outside diameter. We check the outside diameter with this part. Then we want to check the inner diameter. We will check with this part, this side. We will check the inside diameter. And then we want to check the depth. We will be doing with the depth side. This is a basic vernier caliper. Now, there is something called least count. Any idea what is least count? Least count. By the name. By the name, what you can mean? Understand? Minimum. The minimum value we can get using a instrument. That is the least count. Now, a least count. What will the least count of a scale? 1 mm. But some scales has 0.5 mm also. Some steel ruler will have 0.5 mm also. Then, of the vernier caliper, we have digital vernier caliper, we have analog vernier caliper. So most of the analog is normal vernier caliper, which does not have a digital readout. What we should do in the starting, whenever we study, we should study only in the analog. Because digital is very easy. Anyone can do it. But reading in this, it is very difficult. So first you have to learn in the analog. So the vernier caliper, the least count will be normally, if it is not digital, it will be 0.02 mm. 0.02 mm. The least count of vernier caliper is 0.02 mm. 0.02 mm equal to how many microns? 20 microns. Very good. And for the digital ones, it will be 0.01. 0.01. Now, for the normal vernier, analog vernier, can we get the measurement? Can we take a measurement of, for example, 32.33? Will we get a measurement of 0.33? 0.33. Will we get? No. Why? Because I told you the least count is O2. O2. Either you will get 3.2 or 3.4. 3.3 will not come in analog. But in the digital ones we can get, because only we least count to 0.01. 0.1 ಅಂದ್ರೆ we can get 33, 32, 34, whatever it is. And ಇದನ್ನ ಮೆಷರ್ ಮಾಡೋ ಟೈಮಲ್ಲಿ ಏನು ಮಾಡಬೇಕು? Should we measure only one place? Never. Always more than one place you have to measure. Because one place there may be small some irregularity or anything. you will not get the final dimension. So always check some 3-4 areas, and every time you check, note down the value. Note down the value. Never keep in mind, because if you will forget. So always, whenever you get a value, note it down in a book or paper. Always maintain a record. Now next, micrometer. Micrometer. A micrometer, ಇದು ನಾ ಹೇಳ್ದದು ಡಿಜಿಟಲ್ ಅನಲಾಗ್ ಎಲ್ಲ ಇದೆ. ಮೈಕ್ರೋಮೀಟರ್ ಅಲ್ಲಿ ಏನಂತೆ, ಅದು ಮೇನ್ಲಿ ಫಾರ್ ಔಟ್ಸೈಡ್ ಮೆಷರ್ಮೆಂಟ್, ಬಟ್ ಅದ್ರದ್ದು ಕೂಡ ಆಕ್ಯುರಸಿ ಒಂದು 1 micron, 0.01 mm. So either we have the internal micrometer, we have the external micrometer, we have the depth micrometer. There are different types of micrometers. Normally micrometer 0 to 25 mm ನಾವು measure ಮಾಡೋದು, 0 to 25 mm. But for bigger ones we have 25 to 50, 50 to 75, 75 to 100. Such big micrometers are also available. Similarly, this vernier caliper, normal vernier calipers will be 0 to 150 mm. 0 to 150 mm. But the difference between vernier and micrometer will be the next size of 0 to 150 will be 0 to 200 or 0 to 300, 0 to 1000. But in micrometer it will be 0 to 25, 25 to 50, 50 to that type of measurements. We won't have a complete 0 to 100 micrometers. Then next we have the height gauge. Height gauge. Height gauge. Why we use the height gauge? By the name. To check the height. To check the height we use, and also we use to mark, do markings. We have to mark a, for example, in a piece, we have to mark a 10 mm line. We have to mark a 10 mm line. At that time, what we will do? We will set the height gauge to 10 mm, and this height gauge will have a sharp edge. With that, we will be marking. So height gauge is used for height, or checking the height, or doing any markings, to go to the markings. Then next is the most important thing, dial indicator. Dial indicator. A dial indicator is very important because it helps us in checking many things. Whether the piece is clamped straight. The work has to be perfectly straight, right? Even a 1 micron difference, we will not get the proper right angle or anything. So to check if it is proper, I'll show you down how we will check it. Or a cutter is being turned. What if instead of turning properly, it is turning like this? If it is big, we can understand. If this difference is just O1 or O5 or O6, can we understand by naked eye? So for checking that, we will be connecting the dial area, checking the run out. That is known as run out. So all those things we use the dial indicator. This dial indicator, the least count, each line will be O1 mm. Next is the surface plate. What is the surface plate? Surface plate is a block which you will find in all the tool rooms, all the machine shop. It is made of material, granite. Granite is made of cast iron. Normally made of cast iron. It will be perfectly flat. There will be no waviness. There will be no errors. So what we will do? We will keep the paste properly on that. It's like a table. It's like a table itself where we keep all the height gauge and do the measurements or the dial to get everything. Understood? That is the surface plate. Now next, gauge blocks and plug gauges. Gauge blocks and plug gauges. Gauge blocks are nothing but we have the standard sizes used for calibration. Calibration means checking the size. We have the perfect standard size. For example, a block will be 20.00 mm. If the gauge block is that, it will be exactly 20.00, which we can use to compare whether it is the correct, the size is correct also. And we have the plug gauges. Plug gauges, what does plug gauge do? See, a plug gauge will be an item like this. We also call it go no go gauge. Go no go. So what is go no go? What is go no go? Just by hearing the word, what do you feel? You should go or do not go. Right? Pass or not pass. Right? For example, we have a hole. We have a hole of dia 12.35. 12.35. And we have a tolerance of plus or minus 0.1, for example. Plus or minus 0.1. So what will be the limits? It will be 12.45 and 12.25. So the material can be, the hole can be from 12.25 to 12.45. Okay. So you will have a gauge. The gauge size will be exactly 12.45. 25. Exactly 12.25. So the measurement, the hole will be between this. This 12.25 will go inside. Because anyway it will be more than that now. 12.25 will go inside. And then we will have a measurement of 12.45. If the 12.45 also go inside that, what does it mean? 12.45 goes inside. What does that mean? The hole is bigger than 12.45. 12.55 is mere the hole. So is that acceptable? So if 12.45 goes in, it is rejected. Because every time we cannot keep on checking all the dimensions, right? So for that thing, what we will do? We will just put the go no go gauge. 12.4525 will put, okay, it's all going, the hole is okay. We turn it, it will be the same side, 12.45 will be here, 12.25 will be here. Back side 12.45 we put, it is not going in. It is not going in means the hole is less than 12.45. If it is not going in, that means the hole is less than 12.45. So that is okay. That is acceptable. That is what we do with the plug gauges. Any doubts of that? Any doubts? Why we use these plug gauges? Because we want to save time. Instead of measuring individually, we can save time by using plug gauges. Next, handling. Handling of measuring instruments. The two. Sorry. So the tools has to be handled always gently and carefully. Because for example, if this dial and everything now, by mistake our hand touches that will get damaged. A small extra pressure, the piece will get damaged. So we have to always hold it gently and firmly. Sometimes holding it tightly can damage it. Or if you don't hold it properly, it may fall. So let's be caught properly. Then do not drop them. Never drop your tools. That zero error. What is zero error? See, for example, in a vernier caliper, I told we have two parts, right? This moving part is there and fixed part is there. If fixed part only on the zero irutte. There will be a zero in the fixed part. And there will be a zero in the moving part. If moving part on the zero ಇದೆ, fixed part on the zero ಇದೆ. Always ಹತ್ರ ಇರಬೇಕು fixed part to zero, fixed part to zero, and the moving part to zero. The zero of the moving part. ಇದೆರಡು ಒಂದೇ ಲೈನ್ ಅಲ್ಲಿ ಇರಬೇಕು. It should be on the same line. If it is not, that means there is an error. And if there is an error, what will happen? Your measurement will vary. Your measurement will be wrong. So always before using any of the tools, you have to check the zero error. Be it vernier, micrometer, anything. Then some measuring tools will be get affected by the magnets. Magnet can change the readings. So always you have to keep away from magnetic sources. Because when magnet is there, there will be deflections. Deflections in there, there will be changes. So you have to keep it away from magnetic sources. Or hot surface also. Hot, sometimes the machine will be hot. If you keep it near that, or sometimes there will be hot air coming. There if you keep it, it will damage the tool. Not damage the tool, it will damage the accuracy of the tool. Tool also will get damaged, it will damage the accuracy of the tools. Then, after each and every use, the tool has to be cleaned properly. Then, always for cleaning, you have to use a soft cloth. Or tissue, if you are using also, make sure it is a soft tissue. Because these tissues have abrasives. Abrasive means it's like a hard thing. It will sharp. So always use a soft tissue or cloth. Then if you are going to store it for some time, for example, you are going for a vacation. You have your own tool, you have your own vernier caliper, you have your own micrometer. Now you are working in the company. Then your family decides, okay, we are going for a tour, 1 week tour or 1 month tour. In such cases, you are going to store your everything safe, right, in the shelf. Correct? You cannot give it to others. If you give it to others, our tools, how we look, will others look? Huh? No. So we have to put a thin layer of oil. Thin layer. Just little. Not like you have to dip it in the oil. Thin layer of oil has to be put. Put it in the box. Put in the proper box. Keep it safe. Why? Otherwise, there are chances that it will rust. Rust may form. And once rust forms, it won't be easy to move. Understood? Then, storage. I told you, every box will have an original box. Every instrument will have an original box. So everything should be kept in the box itself. Then, too many tools. Don't pile. What do you mean by pile? One never keep it like that. Always keep it dry. Then, calibration. Calibration has to be done. Calibration means making it proper dimension. Calibration. Like how we service our vehicles. ನಮ್ಮ ಗಾಡಿಯಲ್ಲಿ ಒಂದು ಇಷ್ಟು ಕಿಲೋಮೀಟರ್ ಹೋಗಿ ಅಂದ್ರೆ ಸರ್ವಿಸ್ ಮಾಡ್ತಲ್ಲ, ಏನ್ ಮಾಡುತ್ತೆ? ಆಯಿಲ್ ಮಾಡುತ್ತೆ, ಚೆಕ್ ಮಾಡುತ್ತೆ, ಏರ್ ಕಮ್ಮಿ ಅಂದ್ರೆ ಏರ್ ಫಿಲ್ ಮಾಡುತ್ತೆ, ರೈಟ್? ಅದೇ ತರ after some certain time, this vernier caliper, micrometer, whatever tools it is, that has to be calibrated. Then external people, sometimes they will do, others outside people will come in. Now, that calibrate has to be done regularly. Understood? Then, common mistakes with oily hands you are using it. When you use it with oily hands, what will happen? There are chances that it may slip. Then sometimes we'll overforce it. We'll tighten it more. That will also damage the tools. Then okay. Now in the CNC, what are things we have to check? Mainly whenever you are doing in a CNC machine, you have to note the raw material size. It is best, what is the best practice, which is not much followed, but the best practice will be whenever you are doing a program or you are doing a product in a book, always note, always write, keep writing what is the material, what is the raw material used, then raw material size. I'm telling about the raw material size. Then which is the tool used. Tool used. Then finished product size. Finished product size. You have to mention the total time taken. Total time taken. What is the program number used? Every program will have a number. That number, what is the number? This much things you have to write. If you want, you can add more also. Why? Because we are doing a work today. We are doing a work today. Maybe your supervisor or someone, normally, what they will do, all the seniors will be coming from the same campus. For like, they will ask, hey, what happened to that work you did last month? They won't ask tomorrow what we did today. They won't ask tomorrow. For that thing, they are all the same syllabus thing, the seniors. They will ask only next month or maybe after some many days. So at that time, what we can do? We can check the book. We have our record. Sir, this was the thing done. It took this much hours. It took this much minutes. This was a raw material used. This was a raw material size. This was the final size. So for that, even if your company doesn't tell to maintain, you have to maintain the book. Maintain the book. And we have to mention what is the raw material type used. Because in CNC I told what are the materials we can machine. We can use plastic, ABS. We can use MS, OHNS, steel materials. We will use copper. We will use brass. We can do silver. We can do gold. Any material can be done. Just what will change? The feed will change. The speed will change. All those things will change. Only that much will change. And there will be no. And the cutter will change. Depends on the material the cutter will use. That's the only difference. But these things will be common. These things has to be taken care of properly. It should be noted. Even if a company doesn't tell it, note it. Keep it safe because that will help you only. You only it will be helping in the future. And once you start practicing such things now, we will be, we'll keep it as a standard thing. It is a standard procedure. And our juniors also will follow it. Once we start, that practice will be followed by everyone. And then there will be no issues. Sometimes if you even after months, if you need the same program, once you got an order, the same order you are getting after some 1 month or 2 months or even 5 months, we have to make the program again. Otherwise, And making a program is headache because we have to be very careful. So once we have this program number and everything, what we can do? We can just load the same program and run. So we have the number. That's why I told we have to mention the program number also. Understood? Understood? I'll just show you. So this was the regarding the safety and the measuring instrument. From tomorrow you'll be going into the main CNC aspects. What are the axes, how to operate, all those things. Let me see about the machine. I can show it there also. Now I will show you a video how the tool change happens. I told you the tool may change automatically, right?